Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone to ITDR1103. In today's session, we will discuss about lecture 2, which has the foundations of logic. Now, the logic subject will be discussed in two main parts. This part, we will focus on understanding what do you mean by prepositions and predicate. We will introduce the connectives, and they are 5. And, or, not, if then, if and only if. Then we will see about the logical expression and truth table. Now, let's start with the prepositions. Preposition considered as the fundamental object in logic. It is something like numbers in arithmetic. And the prepositions are a statement that is either true or false. Statement is something like a sentence, but it has a true value, which is either true or false. Now, we usually visualize true or false as capital T and capital F, or 1 or 0. All right, and we call this as the truth value of the preposition. As an example, 1 Omani Riyal equal 300 paisa. Now we can easily assign a truth value for the sentence, which is, we can say that this sentence is wrong, so it has the truth value F, or false, or 0, because 1 Omani Riyal does not equal 300 paisa. The pass mark of IDM course is 50, and we can see that this statement is true, because in order to pass IDM, which is Introduction to Discrete Mathematics, you need to have in your grade at least 50. 7 is greater than 5. True. There are 8 days in a week, and you can here decide that this sentence is false because we do have 7 days in a week. Now, from here, you can see that 2 and 3 are true, 1 and 4 are false. Let's see other examples which consider as not a preposition. Something like stop talking. You cannot assign a truth value for the sentence because it is a command, a request. Or the second one, what day of the week is today? And you can see that this is a question. That's why we cannot assign a truth value which is true and false. So those two sentences, 1 and 2, are not a preposition because one is command, you cannot assign a truth value, and the second one is a question where you cannot also assign a truth value. Now we have something else in logic called a predicate, and here is the example of a predicate. X is greater than 5. Now, a predicate is when the value of a variable will depend on the truth value can be assigned to this preposition. Now, X is greater than 5 is a preposition because we can assign a truth value to this statement. However, the truth value depends on the value of my variable here. Now, a predicate is a statement which contains one or more variables. It cannot be assigned a truth value until the value of the variable are specified. For example, if we give X a value 7, then the statement will be true. But if we give this a value 2, then it will be false. Logical structure of a preposition. Now, in logic, we will study the preposition as the sentence you can see here. The sentence says, if the door and the window are not open, not both closed, then the door is not closed or the window is not closed. Now, you can here assign a truth value to this preposition. All right, and we will check how we can assign to those connective. However, you can see that we do have more than a preposition that joined in a long statement using the connectives. Now, what are the connectives? If we go back to our statement here, we call this as a compound statement because preposition, because I do have more than one preposition. The first preposition is window are not closed. The second preposition is door is not closed. So this statement built up from atomic preposition, which is the door is closed and the window is closed. Now, using those two prepositions, we join them together in one compound preposition using the connectives, which they are and, or, not, if, then. Now we will see each connective, how we can assign a truth value if we got it in a preposition. All right, now let's go in deep on the connectives. Now to identify the connectives and or not, etc., we will underline them as you can see here. So we got 5. 1, 2, 3. Then we've got 4, if then, and it has also another name which is implies, if and only if, and it has also another name which is equivalent to. Now the 5 connectives that will be used in logic, they have a specific symbols where it will be given in the following slides. All right, and has a special symbol which is arrow that direct to up or arrow that looks down. Not, as you can see here, if then or implies is one direction arrow. If and only if or is equivalent to is a 2 direction arrow. Now let's see this preposition so we can see how we can write the notation of it is. Let's say that I have P as a preposition which is cows are animal, and we got Q as cows produce milk. Now if we got this symbol which is P, arrow looking up, Q, then this denotes the preposition that cows are animals and cows produce milk. So we take the first preposition, the second preposition, then we just add to it the connective and as it is the symbol used here. The other example here, not P means cows are not animals. So we've got the P preposition as cows are animal, and we added to it the negation. Now let's see this example here. Let P and Q denote respectively the preposition. It is snowing, I will go skiing. First thing we want to do is we should write the English sentence corresponding to the preposition, which is this one. Not P and Q. Then we need to express the English statement preposition and we write them in a symbolic form. So first thing is, let's say that P is the preposition, it is snowing. Q is the second preposition, which is I will go skiing. Now if we got this preposition that you can see here, not P and Q, this represents the statement that it is not snowing. So the first preposition has the first connective, which is the symbol here, and then we've got and This one. The second preposition, I will go skiing. All right. Now let's see if we got this sentence. If I will not go skiing, then it is snowing. So this is go skiing is the second preposition, Q. Then it is snowing is the first preposition, P. Now we can see that it says if. So I have the one direction arrow. If not if I will not go skiing, then it is snowing. So this is the answer of question 1, and here we've got the answer of question 2. If I will not go skiing, then it is snowing. All right. Now let's see in the truth values that can be assigned to connective and. The everyday understanding of the term and is that for P and Q be true, if P and Q must both be true. If P is false or Q is false or both are false, then P and Q is false. And we can express or summarize the possibilities of truth value for and connective by using the truth table. Let's see here. Truth table has a number of columns and a number of rows. The number of rows are always depending on the number of prepositions that I have in a statement. So if we got 2 preposition, we usually number of rows is equal to 2 over number of preposition. You should keep this in your mind. All right. So number of rows here, because I have 2 prepositions, then I must get 4 rows. Now how can we divide the truth value among those 4 rows? We will start by if it is true, true, false, false. This is for the first preposition. Then the second one, it will be true, false, true, false. Now here we've got all the possibilities if I have 2 prepositions, and they are either true and true, true and false, false and true, false and false. Now each this possibility, let's see what is the result. Now as we can see here, and in order to be true, they both must be true, otherwise it will be false. So here we've got true and true is true, true and false is false, false and true is false, false and false is false. So you need to keep this row in your mind, that in true and connective, it won't be true unless the both prepositions has the truth value true. Let's see the second connective, which is or. In everyday language, or has 2 meanings. Either Ali will pass or fail, which means they are not both. Ali cannot pass and fail at the same time. And the other meaning is exclusively, where the possibility of both outcome is included. Now in logic, we are talking about the inclusive, which is either P or Q or both are true, so the result will be true, otherwise it's false. So let's see here again, we've got 2 preposition, 4 rows, and here we've got true, false, true, false. Now for or, we say that we need 1 true, so the final result is true. So the out condition here is it won't be false unless we've got false or false. Otherwise, it will be true. So we need to keep this in our mind, the odd possibility here. The connectives not and if then. The truth table for not is straightforward. If we got P that has the truth value true, then not P is false. If P is false, then not P is true, which is the opposite of the truth value. For F then, let's say we've got the preposition here. Fatima attends tutorial, and Q has the preposition Fatima will pass discrete math. So if we said FP then Q, then if Fatima attends tutorials, then she will pass discrete math. Now from here, the claim is certainly true if Fatima attends the tutorials and passes. So if P then Q is true, it will be true if P is true and Q is true. Now, if Fatima attends tutorial and does not pass, then this claim is false, which means F for P, it has F if she do the reason, but she didn't get the result, the expected result. So this will claim the statement as false. Now, what if P is false? What is if Fatima does not attend tutorial? What will happen? She might pass or not. So the claim is true because it says only what would happen if Fatima attends the tutorial. Because here the proposition says that if she attends the tutorial, then she will pass. Now, if she didn't attend the tutorial, I don't care about the result because we are looking for what will happen if Fatima attend tutorials. So P, if P then Q is true whenever P is false. So we can just summarize what we said there by having the possibilities in a truth table. So my possibilities are true, 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 false, false, true, false, false. Now, as we did in and or, we will look for the odd condition. And here we can say that the odd condition is when I've got the reason true and the result is false, then it will be false. Otherwise, it is true. So the odd condition is if the result is true, if the condition is true and the result is false. The truth table can be interpreted as the only time the implication is false is if the premises is true and the conclusion is false. Premises is the first reason, the condition, the thing that they should do. The conclusion is the result. So you can check those two statements by your own. You can stop the video and try to figure out are these four prepositions true or false. We've got if the sky is yellow, then cows have 6 legs. If the sky is blue, then cows have 6 legs. So you can here see whether those prepositions are true or false, and you can go back to this statement. The last connective we have in logic is if and only if. The connective have this symbol, and it is true when the two prepositions have the same truth value, either true, true, or both. Something like Al-Aqsa is in India if and only if apples are true. So if we say apples are blue, if we say this preposition, which is Al-Aqsa in India, is true, and apples are blue is also true, then the sentence is true because neither one of them are true. False is also true. So the possibilities are, if we got this truth table, then if and only if will be true if I've got the proposition has the same truth value. Otherwise, it will be false. So my odd condition is the two prepositions should have the same truth value in order to get the final one true. So we can here just summarize the basic connective and its truth value. Let's put our prepositions, our possibilities here. True, true, false, false, true, false, true, false. And we will recall only the odd condition in each connective. Now this represents the and connective. Here we can see the or connective. Here we've got not, if, then, if, and only if. All right. Now in and we say that the and is not true unless I've got both of them are true. For or, it won't be false unless both of them are false. For not, if P is true, then it is false. Here we've got if P is false, then not false is true. For if, then it's only false if we've got the reason true and the conclusion false. For if and only if, we say that it is true if we got the preposition with the same truth value. Now if you got the odd conditions in every connective, it will be easier to you to recall this rule whenever you are needing. All right. Now we do have a compound preposition if the preposition built up of or from atomic basic preposition. Let's see this example. We've got the statement as either Thomas Edison or Alexander Bell invented the telephone, and we need to write this in symbol. So first, let's assign a preposition to letters. So here we've got P, let's say, is represent the Thomas Edison invented the telephone. Q represents Alexander Bell invented the telephone. So the statement says either Thomas Edison or Alexander Bell invented the telephone. So first thing we can say that either. So Thomas Edison or Alexander Bell, sorry, or is this simple. So either Thomas Edison or Alexander Bell invented the telephone. However, they cannot be both. So P or Q and not P and Q. This represents the word either. They are not both. Either Thomas Edison or Alexander Bell. Now we've got here the logical expression where P or Q and not P and Q, and we can find the truth value of it by creating the truth table. Now studying this expression will ask us to build a truth table. Right? And this is exactly as what we did in algebra if we got this statement, which is x squared minus 4. So we can analyze this algebra expression. Now, truth table is used to analyze the logical expression that we come up from the statements that we've got. So in order to do the truth table, what we can do is first identify how many prepositions I've got here, how many variables. They are two, which is P and Q. So we will have the first two columns as having the preposition. Now, as we said earlier, the number of rows depends on the number of a preposition. And here we've got two preposition. So we are expecting to have 4 rows. The possibilities are true, 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 false, false, true, false, false. Then we will look at the logical expression we've got, and we will have connective by connective. So the first connective is or. For or, we say that it will never be false unless they both are false. Otherwise, it is true. Then we've got the second connective, which is and. So here we say that it will never be true unless we've got both of them are true. Otherwise, it is false. Then we go for the third connective, which is not. So not true is false, not false is true. Now the final one is the and that combined the first and the second. So here we will see at this column and here this column. So true and false is false, true and true is true, true and true is true, false and true is false. And here we created a truth table for our logical expression. Now, a logical expression has 4 variables. A truth table will have 4 rows. If they are 3 variables, then it will have 8 rows. As we said that number of rows equal to 2 to the power number of preposition, and so on. Now we have a special type of logical expression has a name, which is tautology. Now, in order to understand tautology, let's recall the preposition. If the door and the window are not both closed, then the door is not closed or the window is not closed. So if P denotes the door is closed and Q denotes the window is closed. Now we can see this, the preposition can be written as a simple as using simples as not P and Q, F, not P or not Q. Now let's create the truth table for this preposition. So here we've got our truth table. We'll start with P, Q. We say that we've got 2 prepositions only. So we will have 4 rows, and the rows are the possibilities true, 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 false, false, true, false, false. So the first part of our logical expression will be defined as P and Q. For P and Q, we know that it will never be true unless both of them are true. Otherwise, it is false. Then we should find the not P and Q. So not true is false, not false is true, not false is true, not false is true. Then we should find first not P, not Q. So we in order to find not P or not Q. So not P is, we look at the first column here and we just write the negation of our truth value. So not true is false, not true is false, not false is true, not false is true. Then we've got not Q. Not Q is not true is false, not false is true, not true false, and not false is true. Now we can find the not P or not Q. So here we've got FRF is F, FRT is T, TRF is T, TRT is 3. Final expression is the full expression, which is not P and Q. Then we've got not P or not Q. All right. Now let's find the final expression. So we will be looking at here and here. If false, then false is true. If true, then true is true. If true, then true is true. If true, then true is true. And here we can say that this expression is tautology. And tautology means when the expression we've got has only one truth value, which is true. The other logical expression we've got here, which is contradiction. Let's see this preposition, which is P and not P or Q. So let's build a truth table for this preposition so we understand what do we mean by contradiction. So here we've got P, Q. So two preposition, 4 rows, 4 possibilities. So here true F, true F. First thing we need to get is P or Q. So P or Q, true or true is true. True or false is true. False or true is true. False or false is false. Now, not P or Q is the opposite here. So here we've got not true is false, not true is false, not true is false, not false is true. Then we should have the full logical expression, which is P and not P or Q. And here we look at this column and this column. So true and false is false. True and false is false. False and false is false. False and true is false. And here we see that this logical expression is contradiction, which means the logical expression has only truth value, one truth value, which is always false. All right, so let's see the last part of our session today, which is the logical equivalence. Now, every combination of the truth values of P and Q, the truth values of P and Q, or P and P or not Q, are the same. We call this as logically equivalent. Now, the logical equivalence is when I have two expressions that has the same truth value for every combination of the truth value of the variable. In order to understand more, let's build a truth table for those two logical expressions so we can say that whether they are logically equivalent or not. Okay, so here we've got P, Q. Then we start with P or Q. All right, so here we've got true, true, false, false, true, false, true, false. Now, the first is if we've got P or Q. So true or true is true. True or false is true. False or true is true. False or false is false. Now, not P or Q. Here we've got not true is false, not true is false, not true is false, not false is true. Now we have to identify the second logical expression. We've got that. First, we need to identify the not P, not Q, then not P, and not Q. Here we go. So not P is false, false, true, true. Not Q is false, true, false, true. So not P and not Q here. False and false is false. False and true is false. True and false is false. And finally, true and true is true. As you can see here, this column have the same as this column. So we can say that not P or Q is logically equivalent to not P and not Q, because it has the same truth value for the same combination of truth value we've got here. And here we reach the end of today's session, where we discussed about prepositions and predicates, connectives, logical expression, and truth table. You can go back to exercise 5 to evaluate your understanding for the first part on logic, and then you can attend the next part, which is where we will discuss about deeper information. Thank you for listening. See you in our next session.